This lesson is about iron 26. Iron is present, is ubiquitous. We found it in most paintings because it's contained in earth pigments, so the ochre pigments, and also is present in another very wide diffused popular pigment, Prussian blue. Periodic table iron 26, these are its X-ray lines: K alpha 6.4, K beta 7.1. We start the test as usual for a baseline with a pure cube, metal cube made of iron. There it is. So we see that the signal from iron, of course, is strong, and we analyze it with two filters set up for the tube. The low cave and the routine are stand for routine filter setup. Observation, we notice that, of course, with the low cave the signal of iron is extremely strong, so we are over 150,000 counts. When we do the analysis with the routine filter set, we see that the peak is about 20,000. So basically we are in a situation where if the content of iron is enough, we can just use the routine. So the routine filter setup is the one that we prefer because we can analyze all the spectrum at once. The pigments that contain iron, they contain it as the main element. So it's not really an issue to use the routine to identify the iron containing pigments. Let's see some examples. Our first example is vivianite. Vivianite is an hydrated iron phosphate. Vivianite was used in medieval art for wall paintings mostly, so in North Europe, so German, England, Sweden area, not really for easel painting. Let's look at the spectrum of the vivianite as we have it in pigments checker. The black one is the spectrum of iron cube, so the pure iron, acquired with the routine filter setup, and this one is the spectrum, the red one is the spectrum of vivianite. So we see a count of 3000 counts, so the signal is pretty strong for this pigment, vivianite, where the only element, chemical element that responds strongly to the X-ray is iron. So the content is enough, this pigment is rich in iron, and we have a signal that is strong for our spectra. Let's see the other pigments. Yellow ochre is an hydrated iron oxide hydroxide. The red one is the spectrum of yellow ochre, and it is compared with vivianite. So we see that the signal now for yellow ochre is much lower, so we are in the order of just 1000 counts using the routine filter setup. In the formula of yellow ochre we see just iron as an element that responds to the X-rays. Why the signal is much less? Because natural yellow ochre, so this natural earth, has this iron content, this iron mineral, but also we will find in it mixed quartz, clay, other minerals. The content of iron is actually less than in vivianite. So we can say the same for red earth, red ochre. Here we have an iron oxide. For red ochre also we will find the oxide, the iron oxide, will be mixed with quartz, clay, other minerals. So the signal, you see, it's the blue one for red ochre, is similar to that of yellow ochre. We look now at Prussian blue. Prussian blue was the first of the modern pigments available to the public starting from 1724, and from then it was very popular. That's why Prussian blue is a pigment we expect to find in paintings from 18th century onward. Prussian blue, we see it from the formula, is an iron cyanoferrate. So the main element is again iron, and mixed with other elements, much more other elements, but they don't play a big role in XRF. So eventually what we see is that the iron peak, so the green one of Prussian blue, is the same as that of the ochre. We are in the same range of about 1000.